Hello class, this is a video lecture of Chapter 13. Chapter 13 is titled Compound Interest, Future Value, and Present Value from the Business Math Text. Some of the learning outcomes in this chapter is to find the future value and compound interest by compounding manually, find the future value and compound interest using a dollar future value table, find the future value and compound interest using a formula or a calculator application, which is optional. Find the effective interest rate, and find the interest compounded daily using a table. So I know some of you may be probably saying, well, it's not of interest to me to get any deeper into finance, but we're actually exposed to this a lot more frequently than you might imagine. And these are some of the words that you'll see very frequently if you take a look at, for example, your credit card statement. You'll see compound interest for sure, compounding for sure, future value whenever we're looking at like investments or retirement accounts and stuff like that. Daily compounding, which also matters. So, for example, if you get a credit card and the credit card tells you that the interest rate is 7%, hypothetically speaking, it doesn't just mean that you're going to pay $7 on every $100 because $7 is 7% of $100. If they compound this daily, what this means is that they'll take the 7% and then divide it by the number of days in a year. Usually, I believe it's 360. We'll confirm that in a sec. 360 to get a daily rate, which is usually like 0.00 something. And then they'll use that to compound every single day based on the balance you have. So you end up paying actually a lot more than the 7%. So this does impact your earning potential or your saving potential more so. So it is something that you might want to take a look into. In some loans, interest is compounded once during the life of the loan using the simple interest formula. So in other words, in other loans, interest is compounded more than once during the life of the loan or investment. The interest is added to the principal, the new amount becoming the principal for the next interest calculation, and this process is called compounding interest. So the interest period is the amount of time after which interest is calculated and added to the principal. And compound interest is the total interest that has accumulated after more than one interest period. Another key term, future value, maturity value, and compound amount is the accumulated principal and interest after one or more interest periods. And period interest rate is the rate for calculating interest for one interest period, the annual interest rate divided by the number of interest periods per year. Find the future value and compound interest by compounding manually. Dividing the annual interest rate by the annual number of interest periods gives us the period interest rate. So just to give you an example, 12% annual interest rate divided by 2 interest periods yields a period interest rate of 6%. So this means, like, let's say that there's a 12% annual interest rate and it compounds twice a year, right? So that's important because half of a year is 6 months. So every 6 months, you're going to be assessed the 6% compounding interest, which is not the same as just saying 12% annual. So using the I equals P times R times T formula, we can calculate the interest period, interest, principal, rate, and time. So that's what we need. Simplifying the formula to I equals P times R since T is one period. So the period interest rate equals the annual interest rate divided by the number of interest periods per year. So as an example, a 12% annual interest rate with 4 interest periods per year is a 3% interest rate per period, because all you do is you just divide 4 into 12 and then you get 3. An 18% annual rate with 12 interest periods per year. So then you're looking at an 18% annual rate, right? And then this is telling you 12 interest periods per year. So how many months are there in a year? This many, right? So then that's what you divide it by. So then this is a loan that compounds monthly. And the answer is 1.5%. So you have a 1.5% compounding interest rate per month. An 8% annual rate with 4 interest periods per year. So then again, you divide this, you divide the 8% over the 4, and you get 2%. Using the simple interest formula method. Step 1. Find the end of period principal. Multiply the original principal by the sum of 1 and the period interest rate. The second step is for each remaining period in turn, find the next end of period principal. Multiply the previous end of period principal by the sum of 1 and the period interest rate. And I know that's a mouthful. Step 3, identify the last end of period principal as the future value. So as an example, to illustrate, because that was a mouthful in the previous slide, find the future value of a loan of $800 at a 13% interest rate for 3 years. The period interest rate is 13% since it is calculated annually. Now, first end of year, $800 times 1.13. And the reason why we do that is because we're adding. So if you ever want to find out like, oh, you know, what is a 5%, if I add 5% to $50, right? Or this would also help when you're trying to calculate how much tips you're trying to give in a restaurant. If you have, you know, like whatever amount your bill is, and then you want to increase that by 15%, all you have to do is just multiply that by 1.15, and then you get your final answer. Because whenever we multiply anything by 1, we get that same number, right? So if this weren't here, and it were 800 times 1, it would be 800. But we're telling our calculator that we want to increase it by 13%. And 13% is represented by 0.13. So then by telling the calculator, multiply this by 1.13, we're telling them, give us back our original number and add 13. So that's why we multiply it by 1.13 and we get 904. And I hope that made sense. If you have questions about that, please let me know and I'll be able to guide you in that regard. So the second year, right? This is the first year, 904. Then you bring this over, and then you multiply that by 1.13, and then at the end it's $1,021.52. So then at the end of the third year, you roll that over to the next period over here, multiply that by 1.13 because we're increasing it at 13%. This is the idea of compounding, by the way. It's not just that you're paying 13% of $800. You're always adding on 13% of the balance, and it rolls over each year. Okay, so then at the end of the third year, you have $1,021.52 times 1.13, and that equals $1,154.32. So the future value of this loan, and FV stands for future value in finance, of this loan is $1,154.32. Okay, so now the compound interest equals the future value minus the original principal. So in the example, the compound interest is equal to, and then this is compound interest, CI, equals $1,154.32, which we got from here, minus 800, which is the original amount of the loan, and that equals $354.32. So the compound interest is $354.32. Okay, compare compound interest amount to the simple interest. So now here we have a compound interest, which is the compound interest from here, the same one, $354.32. The simple interest for the same loan would be I equals P times E equals PRT. I equals 800 times 13% times 3. Because we're just getting 13% of $800 times 3 periods, it would be 312. So like I said in the very beginning, whenever you see compounding, you're going to pay more than whatever the rate is. So if it really were just 13%, all you would pay is $312. But since it compounded year to year, you have this much to pay, $354.32. The simple interest would be $312. The difference between the compound interest and the simple interest for this loan, $354.32 minus $312 is $43.32. So taking the compounding loan is this much more expensive than just taking the simple interest loan. Principal find the future value of an investment. So here's the principal of $1,000, an 8% annual interest rate compounded semi-annually. So semi-annually is half years, right? Half year intervals. Find the future value at the end of the 3 years. So find the period of the interest rate, right? 8% divided by 2 equals 4. So this is the interest rate for the period. Determine the number of periods. So 3 times 2 equals 6, right? And the reason being is because it's 3 years. So here we have the 3. And then we have the semi-annual, which is 2. So then there's 6 periods total in 3 years. Okay? Or 6 sets of 6 months, if that makes sense. Calculate each end of period principal. So for period 1, we have the $10,000 originally times 1.04, because that's the interest rate of the principal, and that equals 10,400, but we're not done yet. Okay, so it just repeated here. So going back here, we have the $10,400. For period 2, now we have to take these $10,400, roll it over into the beginning of period 2, times 1.04, and that gives us 10,816 bucks. Now we have to take that, roll it over to period 3. Then we continue doing that for period 3, 4, 5, and then I guess they want us to jump straight through. But the final and the sixth end of period principal is $12,653.19. So then that's at the end of the sixth period what you're going to see as the total amount paid. It would be tedious and time consuming to calculate a large number of periods with the previous method. So you can use table 3-1 in your book, which is the future value or compound amount of $1 on page 461. Find the number of periods and the rate per period to identify the value by which the principal is multiplied. And by the way, if you don't have the actual book, the hard copy of the book, you can always go on my math lab and you'll be able to see the chapter 13 book there. Find the total number of periods and the rate per period to identify the value by which the principal is multiplied. Using table 3-1, find the compound interest on $500 for 6 years compounded annually at 8%. So now we know that since it's compounded annually, there's 6 years, there's going to be 6 periods, 8%. Determine the number of periods, 6. Determine the interest rate per period, 8%, so we don't have to do any math to cut that. Locate the value in the intersecting cell, which is 1.58687. Multiply the principal, $500 times 1.58687, and that equals $793.44. The future value of the loan is $793.44. Okay, and this will make sense if you look at the table. So make sure you look at table 3-1. Compound interest equals $793.44 minus 500, $293.44. Again, using the same table, 13-1, find the future value and compound interest on $2,000 invested for 4 years, compounded semi-annually at 8%. So here, the key words that we need to know here: the $2,000, 4 years, semi-annually. So then the semi-annually implies that we're going to have to cut these 4 years, right? Each year in half, which means that we have multiple sets of 6-month periods, meaning that we're going to have 8 periods. And the answer, if you'd like to work it out, it comes out to $2,737.14. So basically what you'd have to do is you would take the $2,000 and then find the appropriate rate per period by the number of periods, and then you do the method that was previously showed in the other slides. The compound interest, $737.14. What would be the simple interest of the loan? $640, and this is just taking the 8% of the 200, and if you want to cross-check whenever you're coming across any questions that ask you for compound interest and simple interest, if your simple interest is less than your compound interest, it's usually on point. If it's not, then you might want to rework it to make sure. The formula for finding future value will require a calculator that has a power function. The value formula is, so then the future value is principal times 1 plus r, and then the number of periods, right? Where future value, FV is the future value, P is the principal, R is the period of interest rate, and N is the number of periods. So here's an example. Find the future value and compound interest for a 3-year, $5,000 investment that earns 6% compounded monthly. So here, since it compounds monthly, you're going to have to divide, you're going to have to split this 3-year, just looking at the 3-year periods into monthly periods. There's 12 months in a year, and 12 times 3, 36. So knowing that now, we can plug in the formula. So we have FV equals P 1 plus R. And remember, if you remember, this is very similar to just saying the number of periods times 1 plus the rate, right? So this is comparable to putting like the 1.15 for increases of 15%, 1.10 for increases of 10%. So here if we plug it in, we have the future value equals $5,000, and then we multiply that by 1 plus the rate, because this is the rate that we're looking at when we divide this up into its appropriate compound, and then there's 36 periods. So the future value would be $5,983.40. So here we have to follow the order of operations. First you wanna work the parentheses, then the exponent, and then you can do the rest. So the compound interest, $5,983.40 minus $5,000 equals $983.40. So this is the cost of borrowing, or your compound interest. On your scientific calculator, if you have one, it would look like this. You would put in 5,000, open parentheses, 1.005, close parentheses, and then the exponent symbol, and then the 36, and then that'll give you the equals. On the BAA Plus calculator, which is what I use, it's called BAA Plus by Texas Instrument, and it says Business Analyst underneath it. You would press second, and then format, second, enter. Second, you would do second, format 2, and what second format 2 does is it sets your decimal points to 2 places. Enter second reset to go back, enter 36 for the N, which is the periods, 0.5 for I or Y, which is the interest or yield, 5,000 plus or minus, which makes it a minus, present value compute, future value, second quit, and then that should give you the $5,983.40. So I know that's a lot, but let me see. So I found here a video, a picture of what the calculator looks like, the one that I have. So essentially, it does look like it's a whole lot of stuff to enter, but I mean, it's not that hard. So this isn't like a functioning calculator; it's just a picture. But basically, this is the second format number. You would press 2, and then you would press enter to set the decimal points, and then reset to go back. So then basically, you have like all these keys right here, right? And this is the most important when you're in finance. This row right here, because N, which is this key right here, is the number of periods. IY is the number of is the interest rate. PV is present value. That's what PV stands for. PMT stands for payment, and this is mostly used when you're doing like dividends on a stock or on bonds. And then you have the FV button, which stands for future value. So then here, the only thing that we're telling the calculator, and really the nice thing about this finance calculator, is that you can put it in any order, as long as you're telling it what to compute and you give it enough things to compute. So then the most important parts are like here, the N, right? You put in 36N, 0.5Y, 5,000, and then the minus, which is the beginning of the because it is money. That's money out that on your end, and then which is the present value, and then you would go to compute, which is this one, because you're telling the calculator, I want to know this FV. So then by saying compute FV, you're telling the calculator, hey calculator, since I'm giving you this and this and this, I want you to tell me what this is. And then you can actually put it in any order you want. You can do 0.5i, and then you can do the present value, 5,000, negative 5,000 PV, and then 36n for the period, and then compute FV. As long as that compute FV is the last thing that you tell it, then you know it's fine. I think this calculator runs for like 50 bucks or so, but as always, if you have a Apple, there's an app for that, and this is an emulator that Texas Instruments sells, that where you can download like an emulator of the calculator, which is exactly the same thing. The only downfall to this is that if you're going to be taking like a standardized test or something, or like a test for a license or whatever, they won't allow you to use that in the test. Okay, so now back to the presentation. If you have a TI-84 calculator, I don't think anyone has a TI-84 calculator anymore, but you press mode, down, right, enter, apps, enter 36, enter 6, enter O, enter 12, enter down, highlight N, up, alpha, solve, and then you get that amount. Effective interest rate is also called the annual percentage yield, or APY, when identifying rate of earning on an investment. It is called APR, annual percentage rate, when identifying the rate of interest on a loan. The effective rate is the equivalent simple interest rate that is equivalent to a compound rate. So for example, Marcia borrowed 600 at a 10% compounded semi-annually. At 10% compounded semi-annually, what's the effective interest rate? So using the manual compound interest method, you would take 10%, which is given, over 2, because it's semi-annually, which equals 5%. So we know that it's 0.05 effective interest rate, or 5%. First end of period principal, 600 times 1.05 equals 630. And then you take these 630 bucks, you put it over here, and then you multiply it again because it's compounding, times 1.05 equals $661.50. So the compound interest after the first year is $61.50. Effective interest rate. Annual effective interest rate equals $61.50 over 600. Multiplied by 100, you got 0.1025 times 100%, and that equals 10.25%. Using the table method again on table 13-1 in your book, the table value comes to 1.10250. Subtract 1.00 and multiply by 100, and the effective interest rate is 10.25%. Table 3-2 gives you the compound interest for $100 compounded daily using 365 days as a year, as opposed to 360 days as a year. So don't get confused. You want to try to be specific about how it is compounded. All right. Exactly like using table 11-2, which gives the simple interest on $100. Table 13-2 uses $100 as the principal amount. You can refer to page 469. Other tables may use $1, $10, or other amounts. So here's an example. Find the interest on $800 at 7.5% annually, compounded daily for 28 days. First, you divide the principal by 100, as you are using table 13-2, page 469, I hope. $800 divided by 100 equals 8. Find the corresponding value by intersecting the number of days, which is 28, and the annual interest rate, 7.5, and the value of that is 0.576941. Multiply this value by 8 to get $4.62. So the compounded interest on that is $4.62. As in another example, find the interest on 1,000 for 30 days compounded at 6% annual rate. And here we're going to refer to page 466. Divide 1,000 by 100, which equals 10. Locate the cell where 30 days and 6% intersect to determine the value, which is 0.494328. And again, this is not going to make sense unless you refer to page 466, so please make sure you do that as you follow along in the video. Multiply by 10, the interest rate is $4.94. Learning outcomes 13-2, find the present value based on annual compounding for 1 year. Find the present value using a dollar present value table. Find the present value using a formula or calculator application, which is optional. Using the concepts of compound interest, you can determine amounts needed now to cover expenses in the future. The amount of money you set aside is called present value. The simplest case is annual compounding interest for 1 year. The number of interest periods is 1, and the period interest rate is just the annual interest rate, and you don't have to do anything else to it. So here we go. Principal or present value equals the future value over 1 plus the annual interest rate. So here we have decimal equivalent, which is inconsistent with what's in other slides, so I apologize for that. But you get the point. This is basically 1 plus r. Okay. Find the amount of money that the 7th inning needs to set aside to ensure that $10,000 will be available to buy a new large screen plasma television in 1 year if the annual interest rate is 4% compounded annually. Present value equals 10,000 given over 1.04 equals 9,665 and 38 cents. An investment of $9,615.38 at 4% would have the value of $10,000 in 1 year. Some more examples. Calculate the amount of money needed now to purchase a laptop computer and accessories valued at $2,000 in a year if you invest the money at 6%. And that comes to $1,886.79. Now, whenever you see this, invest the money at 6%, this is a very extremely broad term. So it's not like you're gonna walk into a bank and say, hey, I want to have a $2,000 I want to have $2,000 at the end of a desired period at a rate of 6%. So then you put in this amount of money and then you get this after a year. This is more likely to happen whenever you're looking at purchasing bonds, for example. You purchase the bond at what's called a discount, and it's a bond that has a face value of the amount that you want to get. And then the interest is kind of like what, if you can picture it, it's kind of like what fills in the gap between what you initially bought the bond for and what the bond will be at maturity. But I don't think we're going to cover bonds in this class. John wants to replace the tool valued at $150 in a year. How much money will he have to put into an account that pays 3% annual interest? And the answer is $145.63. Find present value using $1 present value table. Using the present value table is the most efficient way to calculate the money needed now for a future expense or investment. Use table 13-3, otherwise this is not going to make sense to you, which shows the present value of a dollar at different interest rates for different periods. So it's on page 475. The first step is to find the number of interest periods. Multiply the time period in years by number of interest periods per year. Interest periods equal number of years times number of interest periods per year. Step 2, find the interest rate. Divide the annual interest rate by the number of interest periods per year. So you have the period interest rates, which equal annual interest rates, divided by the number of interest periods per year. And we'll give an example. Step 3, select the periods row corresponding to the number of interest periods. Step 4, select the rate per period column corresponding to the interest rate. Step 5, locate the value in the cell where the periods row intersects the rate per period column. Step 6, multiply the future value by the value from step 5. So here's an example. The 7th inning, and I think this is a bad example. Let's just pretend like the 7th inning is a name of a company or like a group or like an organization, in case, that makes sense, or in case you were making some sort of baseball reference or something to that effect. So an organization needs $35,000 in 4 years to buy new framing equipment. How much should be invested at 4% interest compounded annually? 4 periods at 4% shows a value of 0.85480. And this will only make sense if you're following in the book. Multiply this value by $35,000. The result is $29,918. They must invest $29,918 at 4% compound annually for 4 years to have the $35,000 at the end of the period. Another example, how much money would you have to invest for 5 years at 6% paid semi-annually to make a down payment of $20,000 on a house? And when you work that out, you get $14,881.80. How much money would you have to invest for 3 years at 10% paid semi-annually to purchase an automobile that costs $20,000? And if you'd like to pause the video to work this out, you can. The answer is $14,924.40. Find the present value using a formula. Optional, but watch either way. The present value formula is PV equals FV over 1 plus Rn. Present value, future value, 1 plus R, or is the 1 plus the rate, and the number of periods. PV is the present value, FV is the future value, R is the rate, and N is the number of periods. Here's an example. Find the present value required at 5.2% compounded monthly to total 8,000 in 3 years. Sorry, I'm seeing double here. All right, so now keywords, compounded monthly, 3 years. So now we know that since there's 12 months in a year and there's 3 years here, we're going to talk about 36 periods. 8,000, 5.2%. Excuse me. So here we have the formula again. Present value equals future value divided over 1 plus the rate times the number of periods. The period interest rate equals 5.2% over 12. And this is the period interest rate. So remember in the very beginning how I told you that they divide up what appears to be a very simple interest rate into 0.000 something? Well, this is an example of that, okay? They take the interest rate that they present to you and they divide it by that, and that's how we determine how much the interest rate is per month. So it's a 0.004333333. So the present value equals 8,000, which is the amount of the loan. Well, the amount of the future value to total, 8,000. So this is the future value over the rate plus 1. So 1 point, and then the rate, we bring it over, and then the number of periods right here to the 36th power. And following the order of operations, we would do the exponent first to solve this, and then work our way to this. $6,846.78. On a scientific calculator, you would do 8,000 plus a parentheses, the rate plus 1, close parentheses, exponent 36 equals 6,846.78069, or just 78. If you have the very cool BAA2 plus calculator like I have, you would press second format to enter, which actually I always have it set at 2 decimal points, so I never really have to do this ever. Okay, I just press 36N, which is representative of 36 periods. Then I tell my calculator that the interest is 0.43333333. Then I tell it that 800 is the future value, so I put 800 minus is the future value, and then compute future value, and then that gives me the answer right away, $8,846.78. Okay, and then let me work it out here on my calculator. So then I have 36n, 0.4333333 8,000 future value, compute. Actually, this is a typo. Not my typo, the publisher's typo. It should actually be compute present value. Okay, and I just caught that mistake. So it's a compute present value, and then you get the $6,848.78. Nobody has this calculator, so I'm gonna skip this. And this concludes the presentation of Chapter 13 in the Business Math text. If you have any questions, comments, or concerns, or you need additional guidance, as always, you can always email me and I'll be more than happy to take the time needed to go over this with you. I hope that at this point in the class, all of you are doing extremely well. As you may have noticed, if you've been keeping track of your grades in the gradebook, at this point, if you do the assignments in my math lab, it is not difficult to get a good grade in the class. If you don't do any of the homework assignments, it hurts your grade a lot. So if there's 2 homework assignments assigned and you get a 100% on one of the assignments, but you don't do the other assignments, that's an F on the homework because it's 50%. So you want to be very careful and make sure that you try. These homework assignments don't take very long to do. They take like 10 minutes to do on my math lab, 10-15 minutes, and you can do them more than one time. So congrats to those, hooray or whatever, for those of you who have been doing it multiple times to try to increase your grade. That's great. You're taking advantage of the fact that this My Math Lab platform gives you the opportunity to do that. If you take it once and you don't get a good grade, then that's indicative of you accepting that not so good grade. But the opportunity is there for you to do it multiple times. In the very beginning of this class, I provided you all with a recommended schedule. And if you're finding yourself struggling with time management, that is exactly the reason why I provided that recommended schedule. So that you can take the 16 weeks that are allotted for this class, or the 12 weeks or whatever, and you can tackle the chapters in my math lab at a recommended pace so that you're not overwhelming yourself the last couple days. Okay? And as always, since I really enjoy um, the being able to give you opportunities for extra credit, and especially because I like to know that it helps me to know that you're watching these videos and taking advantage of these explanations. If you can tell me what this is in an email and just put chapter 13 extra credit in the subject line, and then just tell me what's this right here, this image, I'll give you an extra credit point on your homework assignment. So thank you for watching the video. Again, any questions or concerns, please let me know. For extra credit, email me with what this is, and I will update your grade accordingly. Thanks and have a great day.